Welcome back. In this video, we're going to continue talking about order of operations, but we're going to stop using intermediate steps. Now, intermediate steps are very useful in pedagogy, which is the methods of teaching, and in demonstration, which is what we've been doing so far. We've been demonstrating how order of operations works step by step by step in order to show the priority of each operation and how that priority affects the calculation. We will continue to show things in this series of lectures step by step when it's warranted for us to be able to learn things together. But the intermediate steps I'm talking about right now are the intermediate steps that students make and that lots of people like to make when doing complicated calculations. So intermediate steps are all of the mathematical operations that we performed in the examples we've done so far to get from the original expression to the answer. So each individual operation, and here's the answer, and let's rewrite the expression, and let's do the next operation, and let's write the answer and rewrite the expression. All of that, each of those were intermediate steps. Very useful for teaching and learning. But when you're actually calculating in the real world and in your student work, you really want to avoid intermediate steps when making calculations. The thing is, students often feel safer using them. And I know from experience, because I have been a student for a long time, right? And can remember clearly my student days, that it feels like I can just approach this calculation a little bit at a time. I can write down all my numbers with the decimals. I can do this piece, then this piece, then this piece. And somehow by doing that, I'm avoiding error. The thing is that's not true. It may feel safe, and I know that experience, so I can understand it if you feel it, but it is actually much riskier to do calculations with intermediate steps than it is to just do them in one step. There are two major reasons for that. One is error can sneak in at each intermediate calculation that you make. Each intermediate calculation is an opportunity to make a mistake. So even if there's only a very low probability of making a mistake on any given calculation, if you do many calculations, those errors are inevitably going to crop up and you will make mistakes. These kinds of mistakes are the mistakes when you rewrite a number incorrectly, or when you enter a number into a calculator incorrectly, or when you misread a plus for a multiplication, those kinds of things, and they can compound as you proceed through the intermediate steps. The second source of error when you use intermediate steps comes from rounding. So rounding error occurs when the small amounts that we cut off or add in when we're rounding at the intermediate steps add up in the end to make the whole answer wrong. So a lot of times when you use intermediate steps, if you save a lot of decimals, it will all sort of come out in what people call the wash, right? You'll add a little to this step, you'll take a little away from that step due to rounding, and in the end, all of that will cancel out. The thing is that doesn't always occur. Sometimes rounding errors can cascade and compounds, and you can get answers that are significantly different at the end. Final reason just to care about this is that homework programs are going to ask you to input answers at certain precision. Rounding, if you use intermediate steps, is going to cause you all kinds of problems in that kind of homework. But once you get out of school, it becomes even more important. If you do calculations incorrectly, your bosses are going to look down on that. Regulators that your business may need to supply figures to might get the wrong figures. All kinds of things can happen. It's pretty serious. So what you want to do is when making calculations, you want to minimize your sources of error. The way to do that is to use the order of operations to do your calculations in one step. In order to do this, you're going to have to use something like Excel or a calculator to actually do the calculation, and the effort is going to go into the setup, into getting the setup correct. But if the setup is correct and then you type it in correctly, you will get the correct answer. It's one and done. And you avoid all of the intermediate step risk in order to get good, solid, trustworthy calculations. So this is my advice to you, and it's not just advice. I'm here to help. Okay, so what we're going to talk about now is using a spreadsheet to calculate expressions in one step. How do you do that? So in order to move forward with learning about using order of operations this way, we need to have a little bit of an aside about Excel, because we're going to start using a spreadsheet, specifically in these videos, Excel, to calculate expressions in one step. What I want to do with this is to briefly introduce Excel, because in the introduction I said you don't need to know any Excel in order to do this math course, and it's true, but you do need to learn Excel in the course of doing this math course in order to learn everything that we're learning here. So what Excel is a spreadsheet app. It formats and organizes numbers and data so that we can make calculations, make graphs, and perform analysis. A spreadsheet looks like a grid. You can see a corner of a spreadsheet here in figure 3. It is designed to store numbers efficiently, to make calculations efficient, to make application of formulas efficient. The cells in a spreadsheet, cells are these rectangles that you see in figure 3. They are addressed by row number and column letter. So each cell in a spreadsheet has a unique address. The column letters are across the top, and the row numbers are along the side. As you can see, the cell that we're looking at is cell B4 because it's in column B in row 4. By the way, you can use any spreadsheet program for this. I'm just going to be using Excel. So before we move on with the next set of examples, I'm going to open up Excel and just show you a couple basic calculations so that you get a feel for how Excel works and what it does. This is Excel. The spreadsheet holds the cells. You can click into an individual cell in order to input a number. Like I can type 344 into cell C3 and get 344 into that cell. If I click on it, again, you see that the cell is highlighted by showing this green outline, and that the number 344 also appears up in this area, which is called the formula bar. So you can type input there as well. If you highlight a cell down here by clicking, so I've now clicked onto or into cell E3, I can just type directly into the formula bar, 54, something like that. In order to do a calculation in Excel, the expression you type in has to start with an equal sign. You can either type your expressions into the cells themselves or into the formula bar. So I'm going to type equal sign up here, and I'm going to add 3 plus 7. We know that's 10, right? So now I'm going to hit enter, and Excel has calculated, yes, that's 10. And if we look by clicking onto C3 again, we see that the calculation actually has been preserved here. So the 3 plus 7 is preserved. Once we hit enter, the spreadsheet shows 10. There's a few things when we talk about Excel and we talk about multiplication. The multiplication operator in Excel is the asterisk. So 2 times 7 equals 14. And another thing is things like the square root that we're used to seeing in mathematical formulas does not exist in Excel. If you want to take the square root of something, you have to use something called a function. The function is called square root. It's SQRT. Okay, so what do I mean? In Excel, when you want to do a calculation, you start with the equal sign. So I'm going to hit equal sign. If I want to take the square root of something, I'm going to type SQRT. And you see Excel is helping me with a drop-down menu that's saying, hey, I know some functions that contain SQRT. Is it one of these that you want? And yes, indeed, I want SQRT. I don't have to pick from this list since I've typed out the whole thing. Final wrinkle is it doesn't have to be all capitalized. So in Excel, when you want to feed a number into a function, you do it inside of parentheses. So notice Excel is telling me, okay, you have the square root function. You've opened your parentheses. Now I'm expecting a number. So in fact, it's expecting a number or a cell reference. So I'm going to put in a perfect square. I'm going to ask it to calculate the square root of 25. I close my parentheses. When I hit enter, Excel is going to do this calculation. And here now in cell C5, it has put 5, which is the answer to the square root of 25. So Excel is like a calculator, but it has some things that are different. Like it uses functions like SQRT in order to calculate square roots. But let me just show you before we leave a little taste of how great Excel is. Because, for example, I could have the number 25 here, right? And this number is in cell D4. And now I want to calculate the square root of 25. So in this cell, I can put equal sign SQRT. Notice I used lowercase letters. It does not matter. Excel does not care. For function names, it does not matter whether they're capitalized or not. Open parentheses, and instead of typing 25, I'm going to actually click on cell D4 that has the 25 in it. And notice what happened here. Now we have the function square root, SQRT, open parentheses, and it says D4. That's going to apply the square root function to the number present in cell D4. So I close the parentheses, I hit enter, and I get the answer 5. Why is that cool? That's cool because now I can change the input in this cell and the spreadsheet will automatically recalculate the answer. So if I wanted the square root of 18, I can type 18 into cell D4, hit enter, and cell D5 shows me the square root of what was in cell D4. So Excel can be extremely helpful for calculations, and building cell references into calculations makes them even more useful. We'll stop there and see how our order of operations work merges with what we have just learned. So let's take a look at the formula from example 2.3, which is given here. It was 9 minus 3 over 12 over the square root of 16. And we used order of operations on that, and we got the answer 2. For a computer to understand this expression correctly, it has to be written on one line, but the order of operations has to remain the same as implied in the formatting, which you do exactly the way we did it in example 2.3. You enclose the top and the bottom of the fraction in parentheses in the calculation in order to put it on one line while preserving the order of operations that is implied by the formatting, right? The formatting that clearly separates the top of the calculation, the top of the fraction, 9 minus 3, from the bottom, 12 divided by the square root of 16. Now, as we just saw in the introduction to Excel, Excel uses the SQRT or square root function instead of the square root symbol. So the square root of 16 becomes SQRT, open parentheses, 16, close parentheses. Let's take a look at doing this calculation in Excel. Okay, here we are back in Excel again. We are going to solve example 2.3 in one step. So in order to do a calculation in Excel, you have to type the equal sign first. Equal sign, we're going to open our parentheses to do the top of the fraction, open parentheses 9 minus 3, close parentheses, divided by, open parentheses, and this will get the bottom of the fraction to calculate separately, 12 divided by, we have to use the square root function, SQRT, open parentheses, 16, close parentheses, close parentheses, and notice how Excel has made those inner parentheses around the 16 red to show us that those pair with each other. Excel has all kinds of wonderful things like that that you'll learn as you go. And I'm going to hit enter, and you get 2, which is the correct answer. Now, if we did not use order of operations and we just entered that formula with none of those parentheses, what would we get? I'm going to do that in cell B4, hit equal sign, 9 minus 3 divided by 12 divided by the square root of 16. And you are going to get exactly what this is, which is 8.9375. So that is not the answer that you want. That is not correct. But using order of operations by invoking the order we want, using parentheses, we were able to complete this in one step, and we didn't have to do anything in terms of intermediate steps.